Hi students, welcome back. Now we are going to have the hardware demo of our smart street light system. We are going to see how does an LDR look like, how do we read the value of resistance in light and darkness, and then how does the relay work. All of these and then the final connection of the project in a very step-by-step, minute, explained way. Let us get started now. So students, we are going to discuss the components that we are going to use for our smart street light system. So the first one that we have is an LDR. So this is the LDR and there are two terminals and I have connected them to the two ports on my breadboard. As you can see, there is the cadmium sulfide surface here and the intensity of light will change the resistance of this LDR. Let us check that. To do that, we have a multimeter and I have set it in the resistor mode. So now, when I connect the terminals of my multimeter, which is working to measure the resistance now across these two terminals, so you can see the resistance is around 1.6 kilo ohm. Now I bring my thumb on top of LDR and this is 22.8 kilo ohm. If I remove it slightly, it is 4 or around 5 kilo ohm, and when I give the full light intensity, it is again 1.6 kilo ohm. So this is how the LDR works. Next component that we have for our project is a relay. So here we have the relay. There are three pins on this side. You can see the data sheet. This is ground, this is VCC and this is signal. That means you have to connect ground to ground and VCC to 5 volt. And if the signal value is high, then this relay will be energized. It will make the electromagnet and the connection on the second side will be made. Now what are the connection on the second side? If you read them carefully, this is common, that means it will be connected to one of them. On this side it is written NO, on this side it is written NC. NO means normally open, that means these 2 points are normally open, and when the coil is energized, they will be closed. So they will make a closed circuit. These 2 points are normally closed, so the circuit is already complete. And if the coil is energized, then it is going to make it a open circuit. So these two will open. So if you need a circuit which should be closed on giving the signal, then choose these two. If you want a circuit which should be opened after the energy, then choose these two. So before we move ahead, let us check the functionality of our relay. So here I have ground, so I am connecting it to the ground pin, which is 1, 2, 3. Then I connect my VCC. This Arduino is programmed as LED blink program on pin number 13. So the signal is connected at pin number 13, which is 8, 9, 10, 11, 12, 13. Okay. Now, what am I expecting? LED blink program is going to turn on the signal on pin number 13 as high every alternate second. That means this relay should be energized every 1 second and de-energized again. So let us check. I am going to connect the supply through USB. So you can see that every second when the trigger is coming from pin number 13, our relay is getting triggered and then we can connect the rest of the circuit. So let us start making our circuit now. So first of all, I need to provide VCC and ground from my board to the breadboard. So I take ground from pin which is ground here, and I take ground on this side, and the next one is 5 volt, and that is my 5 volt here. So this pin is my ground and the below one is my VCC. Next, I will connect my LDR. So from ground, I choose one point and this is the LDR connection. Then I take a resistor. This LDR was having the about ranges from 2 kilo ohm, around 2 kilo ohm to 22 kilo ohm. So I have taken a central value that is 10 kilo ohm. So from the same point to VCC, this is the LDR. Now I will take the connection from the junction of LDR and the 10 kilo ohm resistor to A0. So this is the first thing. Now let me connect the board with my supply and upload the program. So the uploading process is completed. Now I am going to just check whether everything is working fine. So I go to pin number 13 and I connect the LED between 13 and ground. Although this is not advised, but some of the LEDs, they can handle the Arduino current. So this one I have tested, it works fine directly without resistor also. So now it is programmed and this is my street light and it is not glowing because I am saying it is daytime. So let me make it night, and yes, it works fine. If I bring my finger on the sensor, then the light is on, and as soon as I remove, the light is off. How much sensitivity do you want? Like you want from a very far distance or very close? How much darkness need to be detected? You can change the value of your sensor where you are comparing, right? Right now we had kept it 400 or something. You can change it and adjust. Now we are going to connect the remaining circuit. That means our relay module. Before that, please disconnect. Never work when the power is on. Never make any new connections. So this is going to be the ground. So I connect the ground, then I connect the VCC, and then I connect to pin number 13. Okay, so now the coil is connected and this is connected at normally open. So let us make a circuit for the LED now. For that, I take VCC here and I take ground as well. So here is my ground. So this is VCC, this is ground. I have to complete this circuit with one forward bias LED. So for that, first of all, I take a resistor and I connect it. Okay, so resistor is done. Then I take the LED and I connect it in forward bias. Now you can see here the circuit is not complete, right? To complete that circuit, I need to take these two wires. One of them will go to the common, one of them will go to the cathode of my LED. Okay, so now these connections are complete. Let us understand everything. Relay, VCC and ground, and it is taking the signal from pin number 13. When it will be energized, it is going to close these 2 points, and these 2 points are going to complete the circuit which is starting from VCC, resistor, LED and ground. In actual implementation, this can be your AC supply as well. These relays can handle 220 volt AC supply. So let us power the board now and check how does it work. We can power using the DC as well. Okay, so now do you see when it is dark, the coil was energized and the LED is glowing. Sunrise, the LED is off and the coil was de-energized. So this is how this circuit works, and you can change the sensitivity level, that how much darkness or brightness you want to detect, by changing your parameter values in the code. So you have seen that the things that we study in theory and simulation, they work well on the actual hardware as well if you are really vigilant and careful. And it's very interesting to get your hands dirty on these components and actually feel the things which are happening around you. So this project was a very helpful one where we realized that how can we save the energy by automated street light system. Now in the next project, we are going to talk about another interesting project called water level monitoring system. Keep learning. Thank you.